This is the screencast for section 1.4, example 4, decomposing functions. Decomposing is the opposite of composing, if you couldn't get that. Composing functions, we took one function and made it an input of another. Now we're going to identify what function was input into the other function. For each function h, find functions f and g such that h could be a composition function. So in other words, I have to identify what function got plugged in and then what function did it get plugged into. So I'm going to look at this with colors. It looks like the inside function here is x plus 1. And then I see another x plus 1 over there, which means the outside function would be everything else. Squared minus 3 and then plus 4. So I can clearly identify that my g of x function is x plus 1. The function it got plugged into, f of x then, is going to be, well, I had to have an input that I plugged g into here, so that will be x squared minus 3. I had to have another input here where I plugged g into, so x, and then plus 4. Now the reason I identified g as being my input function and f being my output function is because that's how the problem told me to do it. It said make f the output, or the external function, g the input function of which you plugged into f. Part B actually has a couple different options. We're going to explore those. I think that the simplest way to look at this one would be if the outside function f was the square root and the inside function was x cubed plus 1. Which means g of x, the inside function, is x cubed plus 1, and then the outside function, f of x, is the square root and then an input variable on the inside, so of x. Option 2, what if g of x was just x cubed? That means f of x is the square root of an input plus 1. So g of x could be identified as just x cubed. And then f of x would be the square root of an input variable, which I plugged g into, plus 1. Either one of those would be perfectly good decompositions of h of x. The now try problem for example 4 is number 25. It also has a couple options for decompositions. I'm going to look at what I think is the most basic one. I'm just going to take the extreme outside, so the absolute value portion, and I'm going to color that blue. And then I think the input function was 3x minus 2. So in that case, g of x would be 3x minus 2. And then f of x, the function I plugged it into, was the absolute value of an input, x. Option 2, you did not have to identify both of these options, but option 2 would be, what if the absolute value and the minus 2 were the outside function and g of x was just 3x? So g of x, the function I plugged in, was just 3x. The output function would be f of x, which is the absolute value of the input minus 2. Now a general rule for these is that your decomposition cannot have just one of them be x. X is not a decomposition of a function. So they have to be a little bit more than just x. So x plus 1 is fine, 3x is fine, x cubed is fine, but the inside function g of x cannot be just x.